Assalamu alaikum and welcome back everyone to Easy Taleem. Today we are finishing the entire trigonometry chapter for AS level mathematics, and honestly Cambridge isn't testing whether you know sine. It isn't testing whether you know cosine or tangent. It isn't even testing whether you can use your calculator or press buttons. It's testing whether you understand the geometry behind these graphs, because every student can press shift sign, right? Very few students know where the second answer comes from. That's why today we'll finally answer questions like sine x is equal to 0.6. So if sine x is equal to 0.6, so you know that if these are the four quadrants 1, 2, 3, 4. So sine x is equal to 0.6 is in actuality these are two equations, y equals to sine x and y equals to 0.6. So solving them simultaneously, this curve is already y equals to sine x. So if I draw y equals to 0.6, it is going to give me two answers. One answer is in the first quadrant and the second is in the second quadrant, because the first and the second quadrant the sign is positive. And about what if cos of 2x minus 15 is equal to negative 0.3? How do you find the values and how many values are there of x in a particular domain that they've given? Or maybe tan of 3 theta equals to 4, and even equations that look impossible without memorizing random values. In the last lecture, we spent almost an hour drawing graphs. Some students asked me, "Sir, why are we drawing graphs if the paper only asks equations?" Sometimes it also does ask graphs, and if you have done good enough learning in your AS mathematics trigonometry, these concepts are going to help you in your A2 level numerical solutions and calculus, etc. So today's lecture answers that question, because every trig equation is actually a graph question diagnosed as algebra, just like I showed you above, that if you're given sine x is equal to 0.6, then actually you are solving two equations, y equals to sine x and y equals to 0.6, and in a given domain. So if your domain is from 0 all the way to 360, right? So you can see that there are two solutions here. The first solution is in the first quadrant and the second solution is in the second quadrant, right? Similarly, if you had to equate sine x to minus 0.3, then minus 0.3 line lies here, and then you will have two solutions. The first is going to be in the third quadrant and second is going to be in the fourth quadrant. And owing to the symmetry of these graphs, this solution, we also write down that in the first quadrant it is theta is equal to x. In the second quadrant, theta equals to 180 minus x. In the third quadrant, theta is 180 plus basic angle x. And in the fourth quadrant, theta is nothing but 360 minus x. And x is the basic angle here. So in today's lecture, we'll cover inverse trig functions. We will also be doing the principal values or the basic angle. We also call it the basic angle. And why calculators only give one answer, right? One answer if you use your calculator, right? The basic angle. And how do you find every solution, as well as the conversion between radians and degrees, the transformed equations, exact value equations, and Cambridge shortcuts. And towards the end, we will do a complete past paper question. Okay, so now first of all, why doesn't the calculator give every answer for sine x equal to 0.5? So if you're given, let me change color and use a new page. So if you're given sine x, where x is an angle, is equal to 0.5, then why doesn't your calculator give all the answers? Now, if you put it in your calculator, of course we know the critical values. Your calculator is going to give you, if you press shift sign, and if your calculator mode is on degrees, then you are going to get 0.5. The answer that it is going to display is going to be 30 degrees, right? Now, is that the only place where the sine graphs equal to 0.5? No, that's not, because if you look at this graph, this sine graph is 1 upon 2 at 30, and it is also 1 upon 2. At 180 minus 30, that is 150, right? Now, so there are two intersections. This is the single biggest misunderstanding in Cambridge, because students just learn this, that if it is positive, then it is ought to be in the first and second quadrant because of ASTC rule, while they do not really understand where this ASTC rule comes from. And then so they just find the basic angle and then also find the second angle in the second quadrant because this is positive. However, the intuition behind it is that you're actually trying to solve two equations, y equals to half and the curve, the sine curve, which is y equals to sine x, and this is how you find two solutions, right? So calculator will only give you one angle, but Cambridge asks for a given domain all the angles. So for example, Cambridge is going to give you x lies between 0 and 360, so for the entire period, okay, from 0 to 360. So in this given domain there are two solutions where sine x is equal to 0.5. Now the calculator isn't wrong, it's doing exactly what mathematicians asked it to do, right? Every inverse function needs one output, right? Because because this is y equals to sine, so you get x is equal to sine inverse of 0.5, right? And inverse is only possible for one-to-one functions, so this must produce just a single output, because if so this is a sine graph and it also travels in perpetuity, right? So it goes from here to here, and we know that the sine graph is symmetric about the origin. So if we try to restrict the domain, then there is a turning point and there is a turning point. So the graph that the calculator actually considers is this one, and when you try to find the other solution of it, when you try to find the inverse of this graph, it goes like this, right? This coordinate, so it moves like this. So the sine, so this is the inverse sine function, okay? Now, so okay, wait a second. So if this is for a restricted domain, for this function to have an inverse, and we draw y equals to x line, then our inverse function is going to be like this. So I drew it incorrectly previously. All right. So I was saying that your calculator isn't wrong to produce one answer, because it's doing exactly what the mathematicians and the technicians input in the system, because for every inverse function needs one output, right? Otherwise it wouldn't be a function, right? We covered all of this in our functions chapter. One input, one output, exactly the same idea. So we deliberately restrict inverse sine to x between negative 90 and positive 90. That angle is called the principal value. So if you put sine of x is equal to negative 0.3, this is going to produce a value in the negative first quadrant, okay? So this is the negative first quadrant, this is the first quadrant, right? And if you put sine of x is equal to 0.3, this is only going to produce a value in the it is only going to produce the value in the first quadrant, where it is 0.3, okay, if this is y and this is theta or x, whatever. Okay, now this chapter secretly connects back to the second lecture we ever did in our AS Mathematics P1 series, inverse functions. It was the third one, functions, then we did composite, and then we did inverse functions. Back then we restricted quadratics. Today we restrict the sine function, and then we will be doing the cosine and the trigonometric functions as well. Exactly the same reason, because without restriction there is no inverse, because the function will cease to be a function, right? So the function must not have a turning point. We learned that, right? For it to have an inverse. So for it to have an inverse, it must not have any turning point. In the closest range to not having a turning point is between this restriction, 90 to negative 90 to 90. Okay. Now, so let's try to do our first example here in order to solidify the concepts that we are learning in this lesson. So if you're given sine of x is equal to 0.5, where x lies between the entire period of the sine function, which is from 0 to 360. So this is the domain, and there is no restriction apart from that. We are not continuing. So I mean, why I'm saying that there is one condition is that you could have said that x lies between negative infinity to positive infinity, right? Or between 0 to 720, or anything of that sort. But we are just restricting it to one period. Okay. So now, if you have to calculate it, you put the inverse in your calculator, press shift and then sign, and put the quantity 0.5. You're going to see something like this displayed in your calculator screen, and this is going to produce an output of 30. Now this 30 is only this angle. So however, if you extend the line all the way up until, not here, up until this 360, then you will see that there also exists another solution, which is also, so if this distance, let me try to show it to you clearly. So if this distance is 30, then we say that this distance is also 30, owing to the symmetry of the first section, symmetry of the first section of this sine curve. Okay, so it is symmetric about the line x is equal to 90 degrees. So if there is this distance is 30, then this distance ought to be 30 as well, and we know that this is 180. Then this value is ought to be 180 minus 30, and we also did all of that in our quadrants as well, that if this is 30, then this is 30. So theta is equal to basic angle alpha here, which is 30, and theta here is going to be 180 minus alpha, which is 180 minus 30, that is going to be 150 degrees in the second quadrant, right? So if somebody asked you where else is sine positive in the given domain, where is our given domain? Our given domain was right here. Okay, so you know now that this value is 150 degrees. Okay, now in quadrant 2, so reference angle or the basic angle is 30, therefore the second angle is going to be 180 minus 30, that is 150. Finish. So now you never memorize, just think about how the graph is behaving. Now you guys can learn this ASTC, which is all students, what was that? So all science teachers are crazy. I don't think that that's a very good way of saying it. Yeah, so this is all students take calculus, the mnemonic for that. Okay. Now, so we did learn where this ASTC comes from, right? We saw how this was positive and this was positive, and so tan is the ratio of, so tan is the ratio of this side and this side, this side and this side, therefore tan is positive here. Cosine is the ratio of this side and this side, therefore it is also positive here. So tan is positive, cosine is positive, and sine is a ratio of this side and this side, which are both positive. So tan, cosine and sine, all three of them are positive, so we just say all, right? So this is all. Now this is just sine. Why? Because if you draw a triangle, this is negative, this is positive, and this is positive, because this hypotenuse is nothing but a relationship like this of base squared plus height squared, right? Now by using Pythagoras theorem, so sine is a ratio of this and this, so positive. Cosine is a ratio of this and this, hence negative, and tangent is a ratio of this and this, and hence negative, so only sine is positive. You can go to our previous lecture by the name of trigonometric graphs in the same playlist, and you will see a detailed lecture explaining where this ASTC gets derived from. Now don't memorize the sentence, understand why quadrant 1 has all positive, quadrant 2 has only sine positive, quadrant 3 only has tan positive, because as you can see, this is negative, this is negative, and this is positive. So sine is a ratio of this side and this side, so negative. Cosine is a ratio of this side and this side, hence negative. However, tan is a ratio of two negative sides, therefore negative upon negative becomes a positive, therefore tan is positive in the third quadrant. And likewise, because this is positive and this is negative, and sine and cosine is a ratio of adjacent and hypotenuse, therefore cosine is positive here. The other two angles, tangent and sine, are negative in the fourth quadrant, right? So every equation afterwards becomes easier. Now let's try to do cos of x is equal to negative 0.6. Now if you look at it, the cos function goes like this, right? The maximum value is at 1, the minimum value is at -1, and it also continues before 0 and after 360 as well. So it's a perpetual curve. But we are given a domain of x lying between 0 and 360. So we will see that at -0.6, we can see that yeah. So this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. So I can identify that this is in the second and the third quadrant, right? And we saw that cos is negative here and negative here because it is positive here and positive here, because all ratios are positive in the first quadrant and cosine is positive in the fourth quadrant. So we are talking about the negative. So in the negative one, we know that this is this angle is going to be 180 minus basic angle alpha, and this is going to be 180 plus basic angle alpha. And how do you calculate alpha? By ignoring this negative sign. So you will put x is equal to cos inverse of 0.6, right? So cos inverse of 0.6 is actually going to give you this value, which is going to determine the alpha for you. Now using this alpha, you will feed this value of cos inverse 0.6 into the second quadrant, 180 minus alpha, whatever that is, okay, whatever that is. I think that's going to be 53.13. So 180 minus 53.13 is going to be 126.87, I suppose. And in the third quadrant, this is going to be 180 plus alpha, which is plus 53.13. That is going to be 233.13. Okay, so that's how you had to solve this equation. Cos x is equal to negative 0.6, where the domain was restricted to between 0 and 360. However, if the domain that we had was restricted between 0 and 180 degrees, then we would just content ourselves with this first solution only, because our domain restricts here, okay, at 180 degrees. All right, in just two quadrants. Now this was done. So now the examiner doesn't care whether you know cosine, they care whether you know which quadrants cosine is negative in. That's the skill. Now let's move away from calculator. If I asked you what sine x is equal to, what x is equal to for sine x is equal to root 3 upon 2. Now we did this in equilateral triangle, that if you have an again, this is covered extensively in our first lecture, in our previous lecture. So if we bisect an equilateral triangle of side 2, which has all the angles 60 degrees, of course, because it's an equilateral triangle, so this becomes 30, this is 60, and this gets bisected into two halves. So if this side was 2, now there are two sides of 1 in the base. So now using Pythagoras theorem, this becomes 3. So now I can see that x is going to be equal to sine inverse of root 3 over 2, which is this over this. So x is ought to be 60. So the basic angle is 60, we already know, right? Now if the domain is given between 0 and let's say 450, so now we are talking about 5 quadrants, 0 to 90, right? Then we are talking about 90 to 180 degrees. Then we are talking about 180 to 270 degrees. Then we are talking about 270 to 360 degrees. And then we are talking about 360 to 450 degrees. Okay, so this is the fifth quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant, and this is the first quadrant, right? So we are talking about 1.25 circles or 5 quadrants, right? So now I will remove it. So So if x is 60 in the first, so x is the basic angle, right? And because this is positive, so we are just dealing with this one and this one. So this is 60, so theta is equal to 60. This is also 60, this is also 60, and this is also 60. In the second quadrant, this is going to be 180 minus 60, that is going to be 120. And in the fifth quadrant, this is going to come all the way from here to here. So this is going to become 360 plus 60, that is 420. Now put this in your calculator. So sine of 60 is equal to sine of 120 is equal to sine of 420. All these values are going to produce a result root 3 upon 2. Right? Now similarly you could do for cosine of x is equal to negative root 3 upon 2. You know that for cosine this you can find this and at 30 degrees, right? So because cosine of 30 is positive root 3 over 2, so the negative of that is going to be in the second quadrant, right? So in the second or the third quadrant, because cosine is negative here and here, because it is positive here and here. So so the basic angle is 30. In the second quadrant, this is going to be 150 because 180 minus 30. And in the third quadrant, this is going to be 180 plus 30, right? Because these angles are 30 degrees each. So this is 210. Now put it in your calculator. Cosine of 150 will be equal to cosine of 210 will be equal to negative root 3 over 2. That's it. Now, if I give you tan of x is equal to 1. Now, tan of x is equal to 1. We saw it in the graphs, which we did in our... Okay, so these are horrible. Let me try to create nice graphs for tan of x. Okay. Although it's going to take a while, but yeah, let's do it properly. So, tan of x. So, if I'm drawing tan of x, so I know that the asymptotes occur at 90 and 270 degrees. So these are the asymptotes, and the tangent graph is 1 at 45 degrees, and it repeats after 180 degrees. I did not do a very good job. It goes like this. So this is at 225, which is 180 plus 45, and it goes like this here, and this is negative 1 at 135, which is 180 minus 35, and similarly it is also negative 1 at 315, which is 360 minus 45. Okay, so if you have tan of x is equal to 1, and so you can see that this one, so y is equal to 1 and y is equal to tan x intersect at 2 points in the first quadrant and in the third quadrant for no restriction given, right? Or if x is between 0 and 360, right? So your answers are going to be 45 and 225. But what if your domain was restricted between 0 and 180 degrees? So if we are putting a restriction here, if we are putting a restriction here at 180 degrees, then you can see that now there is only one solution here. So your only answer is going to be 45 degrees. Now, so far we have solved equations where x appears by itself, right? Unfortunately, Cambridge almost never leaves it that way. Now they'll start hiding x, right? So you expect something of that sort. Sine of 2x plus 30 is equal to 0.4 for a domain x between 0 and 360. Now, but our argument is not x. Our argument is 2x plus 30. So, first of all, double this. So, when I double it, this becomes 0 to 720. And then you add a 30. We are doing some transformation. So, now this is between 30 and 750 degrees. So, this means what? So my domain is now between 30 and 720 degrees for sine of 2x plus 30 is equal to 0.4. Now, first of all, when I look at the quadrants, so this is doing what? So this is 360, this is 720, and then another 30 degrees added to it, right? So if our basic angle is 30, and cosine of and sine of an argument is positive in the first and the second quadrant, or the fifth and the sixth quadrant, or the ninth and the 10th quadrant, right? So we will do, first of all, we are going to say 2x plus 30 is going to be equal to sine inverse of 0.4, whatever that is. Okay, so sine inverse of 0.4, let's say is, okay, let's say that is p, or I can quickly find out the value for you guys. Okay, so that is 23.58. Okay, so this is not p, 23.58. Now, so we can see that my graph starts from 30. So this is the basic angle 30, but my graph starts all the way. So my graph starts from 30, comes to 390, and then 390, and then comes from 390 to 750. So if my basic angle is 23.58, this does not lie in the domain, so we will reject in the first quadrant. Now let's move in the second quadrant, because that's allowed, and then we will move into the third quadrant, into the fifth quadrant as well, and the sixth quadrant. So sine is positive in this domain, in the first, in the second, in the fifth, in the sixth, and in the ninth. And after ninth we don't have any, and ninth is also not complete because sorry, my bad, this is 750, and ninth is also not complete. We just have 30 degrees in the ninth quadrant, because ninth quadrant starts at 720, goes all the way to 810, but we are restricting it at 750. Okay, so in the first quadrant, I will write it down properly. In the first quadrant, theta is equal to alpha, and alpha is nothing but 23.5758. So I will write it down 23.58, and then we will do the rejection and acceptance afterwards. In the second one, this is 180 minus alpha. So this is nothing but 180 minus 23, which is approximately 156.42. Then in the fifth quadrant, because third and fourth are negative, in the fifth quadrant, theta is equal to 360 plus alpha, which is 360 plus 23, which is 380.58. And then in the sixth quadrant, because that's again a positive quadrant, this is the sixth quadrant, so that is 540, 360 plus 180, 540 minus alpha, which is going to be equal to 516.42. And then seventh and eighth quadrant are negative. The ninth quadrant is going to be 720 plus alpha, which is going to be equal to 743.58. Now, if you look at the given domain, which is between 30 and 750, the given domain is between 30 and 750. So you are going to reject this one, and you are going to accept all the rest. Now, these are not the answers for x. These are the answers for 2x plus 30 is equal to this first answer, 156.42. The second answer is 2x plus 30 is equal to 380.58. The third answer is this one, which is 2x plus 30 is equal to 516.42, and the last answer is 2x plus 30 is equal to 743.58. Okay, now you just do the algebra, find x for all these four answers, and this is going to give you the answer for this given problem. Okay, now once you do that, you're going to find the values. I can try to do it quickly. This is 126 divided by 2, so 63.225 is going to be x here. This is going to be 350 upon 2, which is 175.2829 approximately. This is going to be equal to 516, 250, 258. No, sorry, 516 minus 30 is going to be 486, which is going to be equal to 243.21, and this one is going to be equal to 713, 356.5, so approximately 357, approximately equal to, right? So these are all approximate values, correct to 2 decimal places, or so correct to 2 decimal places. Okay, so these are the answers you are going to get for this problem, where sine of 2x plus 30 was equal to 0.4. Okay, now you can feed all these values in here, and you will see that the answer that you're going to get is approximately equal to 0.5, because these are not the exact values. We are taking certain degree of precision, it's not the exact values, right? Now, so these are exactly the same questions, nothing new. You just had to find the principal value and then find the second and third and fourth angles depending on the domain that you're given. But you have to make sure that you are adjusting the domain. Okay. Now, why did it happen? So first of all, this function came about because the first one would have been sine of 2x, the second one would have been sine of x plus 15, and the third one would have been, the second one would have been sine of so how do you come to 2x plus 30? So firstly, we do the horizontal compression. So this sine curve, where it was completing one period in 360 degrees, now it's completing 2 periods in 360 degrees. So our curve goes like this. So our curve goes like this, and similarly, so the curve goes like this. Okay, I just tried to seek help using these. Now, so this is our revised curve for sine of 2x, and then so if this was g of x, now we do g of x plus 15. So instead of x, we will write x plus 15. So this becomes sine of 2 times x plus 15 is 2x plus 30, right? So now, if it is plus 15, our curve is going to move 15 units to the left, and this is our actual curve that we are looking at. Okay, and this is going to go all the way till here. So you had to find 0.4. So 0.4 has how many solutions? So it has a solution here. So the line 0.4 cuts like this. Okay, so this value that we got is 0. I'm trying to use a sharper pen in order to avoid some messy stuff. So this value is 357. This value is 243, as you can see, and this value right here is 175.29, and the first value is going to be 63.23. Okay, so this is how you got your answers. Okay, so again, this is the hidden geometry behind the graphs. Okay, now, what is the Cambridge philosophy for this? So Cambridge loves making simple ideas look difficult. Your job is making difficult questions look simple. So now you've learned why calculators never give more than one answer because of one-to-one function, how it was fed by mathematicians and technicians into the calculator, how inverse trigonometry actually works, and how transformed equations begin. Now we are going to solve questions using radians. We are going to do multiple angle equations. We are going to do identity based questions, and and towards the end we are going to do a full Cambridge past paper question that combines everything we have learned throughout this chapter in the last lesson and in this one. That's where students usually lose the most marks and where A grade students separate themselves from the rest. Now, so let's try to do a radian question in which, so let's say you're given sine of 2x plus pi upon 6 is equal to 0.6. So for such a question, if your domain is given like 0 to 2 pi, now it should be, first of all, it should be adjusted to 2x. So 2x, or let's say initially you were given 0 to pi, so 2x will make it from 0 to 2 pi, right? And then 2x plus pi by 6, we add pi by 6 to all the sides, so this becomes pi by 6 added to 2 pi is 13 pi by 6, right? And the left hand side is going to be pi by 6. So now we start in a quadrant system. If this is pi by 6, so we start from pi by 6 and go all the way to 13 pi by 6. Okay, so if you have to solve it, so what is going to be sine inverse of 0.6 in radians? Let's see that. So sine inverse of 0.6 in radians is going to be, give me a second, this is 0.644. okay, so this is 0.644. Now what is pi by 6? Wait a second, let me see. So pi by 6. Pi by 6 is 0.536. 526, sorry. 524, sorry. Pi by 6 is 0.524. 524. Now clearly, so this is starting at 0.524 and goes all the way to 2 pi plus 0.524. So clearly this 0.644 is somewhere here. So clearly this is in the domain. So first angle is going to be 0.644. The second angle is going to be in this quadrant and hence pi minus 0.644. The third angle is going to be in the fifth quadrant, but which is going to be 2 pi plus 0.644, which I can see is going to cross this and not, so we are going to cancel this. We are just going to use these two. So this is going to be your answer for this argument, 2x plus pi by 6. So 2x plus pi by 6, 2x plus pi by 6 is going to be equal to 0.644, which is nothing but sine inverse of 0.6. Put your calculator in the radians mode, please. Do not miss that. So this is the first, and then you adjust it. So this is 0.644, subtract pi by 6, which is 0.524, and then divide this entire thing by 2 in order to find the value of x. So this is the first answer. The second answer is going to be 2x plus pi by 6 is going to be equal to the second quadrant, which is pi minus this answer. So pi minus sine inverse of 0.6, and sine inverse of 0.6 we know is 0.62644. So 3.142 minus 0.644. So and then x, therefore x is going to be equal to this 3.142 minus 0.644 minus pi by 6, which is 0.524, and whole thing divided by 2 in order to find the value of x. You can put it in your calculator and verify by plugging this back into this equation and finding the sign of it in the radians mode to see that this indeed is 0.6. okay, now so radians are not different mathematics. You just convert this, you just have to ask yourself that what changes here. So nothing changes here, only the units change, and because the units have changed, you are going to do the calculations in your calculator using the same units, right? So graphs don't care whether you measure angles in degrees or in radians, because in a graph, the graph of sine behaves in the same manner. So this could be 2 pi in radians or 360 in degrees. This could be 180 in degrees and pi in radians, right? So the graph doesn't change whether you put your calculator in the radians mode or keep it in the degrees mode, right? So this is how you solve this entire thing. Now notice something, we never solved sine of 2x plus pi by 6, right? So in A2, of course, you are going to learn how to expand this, right? So this is going to expand into sine of 2x cos of pi by 6 plus cos of 2x times sine of pi by 6. So you are going to learn that in your A2 levels. However, for now, and then you expand this cos 2x further into 2 cos square x minus 1 and sine 2x into 2 sine x cos x, right? And we are going to do all the intuition in the A2 as well of why these identities and compound angle formulas exist. However, right now you just have to use your graph intuition and the quadrants knowledge to solve these by adjusting the domains and then finding all the angles and then doing the algebra in order to find the desired values or value of x. Okay, now if you're asked to find out tan of 2a is equal to negative 2.1, so first of all this must tell you that, and if a lies between, let's say, 0 and 2 pi, right? Let's say, so this must tell you that this is in the second and fourth quadrant, first of all. And by now I hope you guys are well versed with this quadrant system, that how to spot which ratio has negative values and positive values in which quadrants respectively. Okay, so 2a is going to be in 8 quadrants between 0 and 4 pi, right? So if there are 8 quadrants, then we are doing second and fourth and fifth and eighth, right? So in the second quadrant, the basic angle alpha is going to be equal to tan inverse of 2.1. We are going to take the absolute value disregarding the negative. So this is going to be equal to, in the second quadrant, this is nothing but pi minus this basic angle alpha. Let's say that this is alpha, right? So I will just use, this is in the second quadrant. In the fourth quadrant, this is going to be 2 pi minus alpha. In the sixth quadrant, this is the sixth quadrant, right? This is the second, this is the sixth, this is the fourth, this is the eighth. So we have done the second, we have done the fourth. Let's do the sixth one now, which is 3 pi minus alpha, and the eighth angle is going to be 4 pi minus alpha. Whatever alpha is, you put this in your calculator in the radians mode and you're going to find the value of it, right? So this is as simple as that. Now there is a beautiful insight to it. Students often write 64.54 instead of negative 64.54. If you're doing this in degrees, you are going to get 64.54. If you do tan inverse of negative 2.1, you are going to find out negative 64.54, right? So tangent is negative, calculator gave quadrant 4, right? So sorry, when you put this in here, calculator gave you the first quadrant, right? Now, but if you put this negative 64, the calculator is going to give you negative 64 value. So this negative 64.54 in the negative first quadrant is the same as 360 minus 64.54 in the positive fourth quadrant. So negative 64 and 295.46, they both are one and the same in degrees, right? So a general strategy to solving trigonometric equations in AS level pure 1 is never start solving. Instead ask, which function is this? Is it a sine function? Is it a cosine function? Is it a tangent? And then see which graph is it. Is it a sine curve? Is it a cosine curve? Is it a tangent curve? What is it? What's the period? How many multiples do you see with your desired angle or the variable? What's the domain? Have you adjusted the domain? So if you're given 3x plus 15, are you keeping the domain as it is in x, or have you adjusted this with into 3x plus 15? That's very important. Is there a hidden substitution that you can make? So this 6-step checklist solves almost every question. Now, we know, let's do an identity based question as well, and then we'll be done. So if you're given 4 cos of theta plus 15 tan theta, and let's say that this is equal to 0, so how do you have to solve it? So first of all, expand this tan theta. So this is 15 sine theta over cos theta, and this is 4 cos theta, and this is 0. So take the LCM, multiply both the sides by cos theta, so you get 4 cos square theta plus 15 sine theta equals to 0. Now there is a cos square, there is a sine, and we know that cos square is same as 1 minus sine square because of the Pythagorean identity, which is cos square theta plus sine square theta equals to 1. Therefore cos square theta is equal to 1 minus sine square theta, right? Plus 15 sine theta equals to 0. So now this becomes negative 4 sine square theta plus 15 sine theta plus 4 is equal to 0. So now I can take everything to the right hand side, so the signs are going to change. So now this becomes 4 times 4 is 16, so this is 4 sine square theta minus 16 sine theta plus sine theta minus 4 is equal to 0. I can take 4 sine theta common. This gives me sine theta inside the bracket and minus 4. And I can take 1 common, and this gives me sine theta minus 4 inside the square bracket. And I can take the square bracket common, which is sine theta minus 4. And this is 4 sine theta plus 1. So definitely this can't be, this doesn't exist. So sine theta is equal to 4 is not possible because sine theta ranges between -1 and +1. So this is not possible. Only this is possible. So sine theta is equal to -1 upon 4, definitely in the third and fourth quadrant, as you can see here. So this is the first and second quadrant. This is the third and fourth quadrant where sine is negative. So -1.4 is going to be here, 180 plus basic angle alpha. Basic angle alpha is going to be sine inverse of 1 upon 4, which is 0.25. So sine inverse of 0.25 is going to give me this angle, but I am not interested in this one because here it is positive. I am interested in this one, right? So this is 180 plus alpha, or pi plus alpha if you're doing it in radians mode, and this is going to be 2 pi minus alpha, or 360 minus alpha. Okay, so we used the identity of tan equals to sine over cos, and we also use the identity of cos square theta is equal to 1 minus sine square theta using the Pythagorean trigonometric identity, right? Now, so this is how you're supposed to do it. Now, the common mistakes that students make in their trigonometric questions is that they only write calculator answer, that is just one, and they are not writing the multiple solutions. They lose the final method marks. They identify the wrong quadrants, which I told you multiple times that you don't even have to learn ASTC. You can just use it through that this side is positive, this side is positive, this side is negative, this is positive, this is negative, and this is negative, and this is positive, and this is negative. So using this intuition of a Cartesian plane, you can identify which ratios should be positive or negative, right? They apply the wrong period. So students use 360 degrees for tangent, which is not the case. The period is 180 degrees for tangent. They forget to adjust the domain, and they find solution outside the interval. And you saw that in the 3 questions that we did, we were we were not oblivious of that. We were very mindful of that. They do not reject impossible sine value the way we did here, that sine theta can never be 4. I mean, at 4, the sine wave does not even exist, right? You know that. So that's impossible. The bigger picture is that I want you to notice something. This chapter wasn't actually about trigonometry. It was about recognizing patterns, graphs, functions, inverse functions, transformations, circular measure, quadrants, unit circle, identities. Everything came together here. That's exactly how Cambridge designs the syllabus. And now, believe it or not, the entire trigonometry chapter is finished in just 2 lessons, but provided that you are doing the exercises from your textbook. Our next topic is series. At first, it looks completely different, but you're going to discover something surprising. Series, AP and GP, those who are coming from AdMath background are already familiar with this one, and those who are resitting the ES, of course, they are aware of this. Series is actually another chapter about recognizing patterns, and after series, only calculus remains, which means we are entering the final phase of entire AS mathematics syllabus, and as per our target, we are planning to inshallah cover it by the 24th of July. Now, if you have watched every lecture from functions through coordinate geometry, circle, circular measure, and trigonometry, and today's trigonometric equations, you're no longer studying isolated chapters. You're building one complete mathematical language, and that's exactly how A grade students think. So if you are preparing for 9709/12 along with S1 or M1 or whatever, in AS Mathematics and you're serious about scoring an A, don't leave your preparation to chance. So if you're sitting in October, November 26 or preparing for May, June 27 and have started earlier, at Easy Taleem, we don't just solve questions, we teach you how Cambridge thinks. Every lecture is structured from first principles, connected across the syllabus and built around examiner patterns and real past papers. If you'd like to join our complete AS Mathematics program, you can WhatsApp me on +92 329 3028485. And you can also, whether you are a school student, academy student or private candidate, you are welcome. If you want to follow us on our Instagram, where we are regularly posting challenge questions, the Save Worthy Carousel post and reels on all these topics. You can follow us on our Instagram channel where we go by the name of Easy Taleem, EASYTALEEM. It's about learning the right way. The journey from zero to an A isn't about intelligence, right? I'll see you guys in the next lecture on series on Saturday.